All right, let's dive right in. Today, we're talking about something called a squint, or to use the medical term, strabismus. It's what happens when the incredible teamwork between our eyes, well, breaks down. We're going to unravel what happens when that perfect partnership falls out of sync. But before we can really get into what happens when things go wrong, we have to ask a much more basic question, right? Why do we even have two eyes in the first place? I mean, what's the point? The answer is actually the key to this whole story, and it's pretty amazing. And here it is, plain and simple. We have two eyes to see the world in 3 dimensions. You see, each eye captures a slightly different angle of the world. And then our brain pulls off this incredible magic trick. It fuses those two flat images together into a single, rich 3D picture. That whole process is called binocular single vision, and the result is stereopsis, what you and I just call depth perception. And just look at the machinery that makes all that 3D magic happen. Each one of your eyes has 6, count them, 6 specialized muscles, and they're all working together in this perfectly coordinated dance to aim your vision. It really is like a biological ballet. So what happens when one of the dancers is out of step?
Well, that's exactly what a squint is. It's a disruption in that dance. The medical world calls it strabismus. So let's break down what this condition really is.
At its very core, strabismus just means the eyes are misaligned. So while one eye is looking right where it's supposed to, at the fixation point, the other eye is wandering. It might turn in or out or up or down. The bottom line is the eyes are no longer a team. They're not looking at the same thing at the same time. Okay, so when a doctor first sees a patient, maybe a little kid, who seems to have a squint, their first job is to figure out one very important thing. Is this a real misalignment, or does it just look like one? And that brings us to our first major distinction. There's what's called an apparent squint, which you see a lot in infants. Sometimes facial features like a wide bridge of the nose or little skin folds at the inner corner of the eye can totally create the illusion that the eyes are turned in, when in fact they're perfectly straight. But then there's true strabismus, and that's when there is a real, measurable misalignment of the eyes. So let's say we've confirmed it's a true squint. The next question we have to ask is this deviation obvious? Is it there all the time? Or is it something the brain is constantly fighting, working overtime to keep hidden? This is the difference between a latent and a manifest squint. A latent squint is just a tendency for an eye to drift. Your brain is putting in a ton of effort all day long to keep those eyes aligned. That hard work can lead to things like eye strain and headaches. A manifest squint, on the other hand, is what happens when that control system breaks down and the misalignment actually becomes visible. Now, you're probably wondering, if a latent squint is hidden, how in the world does a doctor find it? Well, it turns out they use this incredibly simple but really clever little test. It's called the cover-uncover test. The doctor has the patient stare at something, and then they cover one eye. That single action, covering an eye, breaks the brain's 3D fusion system. And then the doctor just watches. They watch to see if the uncovered eye moves. And then, this is the really important part, they watch to see what the covered eye does the exact moment it's uncovered. And the results are just brilliant in their simplicity. If the eye that was uncovered the whole time has to move to focus, that means it was already drifting off. That's a manifest squint. But, and get this, if the eye that was under the cover moves to get back in line as soon as it's uncovered, that reveals that hidden tendency. That's a latent squint. And if nothing moves at all, perfect alignment. So simple, but so powerful. Okay, so for the squints that are visible, the manifest ones, we've got one more layer to peel back. We need to know if the amount of deviation, that angle, is always the same, or if it actually changes depending on where the person is looking. This is the difference between concomitant and paralytic strabismus. With a concomitant squint, the angle of the eye turn is consistent. No matter where you look, up, down, left, right, it's the same amount of misalignment. But with a paralytic squint, the angle changes. It gets way worse when the person tries